We'll see in another problem based on the concepts of D'Alembert's principle. The figure, it shows that two blocks of weight 60 Newton and 140 Newton are placed on a two inclined surface and connected by an inextensible string. Calculate the acceleration of the system and the tension in the string. Take the coefficient of friction mu as 0.2 for both the blocks, between the blocks and the plane. From the image, it is understood that the blocks, 60 Newton block is inclined at a 60-degree plane, and whereas 140 Newton block is inclined at a plane of 30 degree. Both the blocks are connected with an inextensible string through a pulley. We have to find the acceleration of the system and the tension which acts in this string to maintain the system in equilibrium condition, that is in the dynamic equilibrium conditions. So first we have to write down the given data. For block A is 60 Newton. Block B is 140 Newton. The coefficient of friction is mu is equal to 0.2. So then we have to draw the free body diagram for block A and then block B. When we draw the free body diagram for block A, that is 60 Newton, here, as always said, that the weight will act perpendicular to the ground plane. The weight is acting perpendicular to the ground plane. When we resolve to vertical component, it will be of W sin 30. When we resolve to horizontal component, it will be of W cos 30. The normal reaction force is always acts perpendicular to the lying plane. This is the normal reaction. Since the block is inclined, normally the block will move downwards to the ground surface. So the direction of motion will be downwards. Whereas in this case, the block in the other end is of higher weight. So we have to assume that the block moves in the upper directions. That is on the this direction. So that the frictional force will act in the opposite direction. Likewise, the D'Alembert moment of inertia, MA, will also act in the opposite direction. Inertia force. By resolving the forces normal to the plane, here the vertical forces are NR minus NR, it's acting upward direction, so plus NR. Since we resolved, we'll get 60 sin 30. It is in the downward direction, therefore NR is equal to 30 Newton. We'll get the value as NR is equal to 30 Newton. Resolving the forces along the plane, that is parallel to the plane, T is in the positive directions, and the resolved force is in the negative side of the X, so it is minus 6 cos 30. Likewise, FM, MA. FM, we know the formula for FM. FM is equal to mu into NR. Mu value is assumed as 0.2 into 30. MA, for M, we have to substitute 60 by 9.81. We'll get the value T minus 6.116A is equal to 57.96. This will be the equation 1. By solving this, we'll get the equation as T minus 6.116A is equal to 57.96. Similarly, we have to draw the free body diagram for another block. As already said, that the weight will be acting perpendicular. The normal reaction is in the opposite direction. When we resolve the weight, for a vertical component, it will be 140 sin 60, whereas horizontal component is 140 cos 60. The tension in the string to maintain the system in equilibrium, it is opposite to the assumed direction for the block A. Here, the direction of motion, it is in the downward direction. So the MA will be in the upward direction. Similarly, the frictional force also will be in the opposite direction. By resolving it to the vertical component, we'll get the NR value as 121.24 Newton. Resolving the components horizontal to the plane, that is parallel to the plane, it will be 140 cos 60, it is in the positive directions, minus T, it is in the negative direction, minus FM, minus MA. We have to substitute the known values for FM. mu into nr, we'll get the equation as t plus 14.27a is equal to 45.76. In the calculator, we can solve these equations. In the two unknowns. Using those equations, we will get the value for A as minus 0.598 meter per second square, and T value as tension of the string will be 54.3 Newton. Since the acceleration, what we have calculated comes in negative, the assumed direction is wrong. We have to assume the direction in opposite side. The movement of the object will be in the opposite side. Thank you.